adding 29 milliliters of 30% hydrogen peroxide. Then we're gonna fill up with DI water to the 100 milliliter mark to make an 8.6% solution of hydrogen peroxide. Now we're going to prepare a 0.2 molar acidified potassium iodate solution by first adding 10 milliliters of 1 molar sulfuric acid to 90 milliliters of DI water. Weighed out 4.3 grams of potassium iodate that we're going to add to our sulfuric acid solution. So now we're boiling 100 milliliters of water. We're going to add some of that, some starch, mix that up, and we're going to add it back to the water. We're going to make a starch solution. So now the water's come to a boil. We're going to add 5 milliliters to our stock starch solution. This guy. And mix that up and then add it back. So now we have the 5 milliliters of starch mixed with the 5 milliliters of the boiling water. Gonna add it back into our boiling water. Add it all in.
And we're gonna boil it for
mix that all up.
About another 5 minutes.
We're weighing out 1.5 grams of malonic acid. Weighing out 0.4 grams of manganese sulfate monohydrate. Now we're measuring out 40 milliliters of the starch solution with the manganese sulfate and the malonic acid. So now we're measuring out 40 milliliters of the 8.6% hydrogen peroxide solution. Now we're going to measure out 40 milliliters of 0.2 molar acidified potassium iodate. So here is the 40 milliliters of 8.6% hydrogen peroxide, and here is the 0.2 molar of acidified potassium iodate. 40 milliliters of this too. Gonna add it in. And finally, we're gonna add in 40 milliliters of our
starch malonic acid.
Starch malonic acid, manganate solution, and reaction.
Yo, what's this?
This is the chemistry elevator.
Okay, explain to me, what's this?
This is an example of the yellow-blue switcheroo, which is an oscillation reaction. So there's two reaction mechanisms taking place here. So there's two reaction pathways. Then both act like a pendulum. So one reaction starts like at the top of the pendulum, dropping down and transitioning as the other reaction pathway takes over, bringing it to the top of the pendulum on the other side. Thus, both reactions stay far away from equilibrium. The color changes observed during the reaction are due to the oscillations in the concentration of iodine, I2, and iodide ions, I-. The yellow color is attributed to an increase in the I2 concentration. The dark blue color arises from the formation of a starch-iodine complex as both the I- and I2 concentrations increase. The colorless solution is caused by the decline in I2 concentration and the continued rise in I- concentration. The dark blue starch-iodine complex consists of amylose iodine. The color of the complex, blue-black, comes from the pentiiodide anion I5 formed from when the I2 and I- concentrations are elevated. Though normally an unstable anion, I5 becomes stable as part of the starch complex. The overall Briggs-Rauscher reaction is this: IO3 plus 2H2O2 plus CH2CCO2 H2 plus H plus, which becomes CCO2H2 plus 2O2 plus 3H2O. The overall reaction may be broken down into two component reactions, in which an intermediate compound, HOI, is generated and then consumed. So right here, the HOI is generated by IO3 plus the H2O2 plus H plus, which becomes HOI plus 2O2 plus 2H2O, and the HOI is consumed in the next equation, which the HOI plus CH2CCO2 H2, which becomes ICHCCO2H2 plus H2O. In the proposed reaction mechanism, the concentration of HOI rises and falls, triggering oscillations in the I2 and I- concentrations in solution. When the I2 and I- concentrations are high, the solution is blue. When I2 is high and I- is low, the solution is yellow. And when I2 is low and I- is high, the solution is colorless. The oscillations continue until either malonic acid or ions are consumed.
Okay, thanks for all that. I'm gonna late for the next class.